Hello students, in this video we will be seeing how to simulate a VHDL or Verilog program by using Vivado software. Okay, so for that can open the software in the start menu. After the installation we will be having Xilinx design tools folder. So you have, if you click start menu, all programs, last you have Xilinx design tools. Here also it will be there, or if you see in the start menu also you have Vivado 2018.1. Anyway, you can open the software. If you click Vivado 2018, the software will be opening. So we could wait till the software get opened. So Vivado software is opening up. So these are the things will be there. So these are the recent projects what you have already worked on. So initially first to go to create project. Click create project. A window will be coming. In this create a new Vivado project, click next. So give the project name. Let me give the project name as now I am going to simulate AND gate. So test, and I'm giving one sum name and clicking next. So initially it will be selected as RTL project by default, so you can use that itself. Click next. In this you have to select in which board you are going to implement this program. For that there are lots and lots of parts, boards available in our software. So in order to select the board, click boards option here. You can see this, click boards. In our lab we have Basys 3 kit, so we are going to implement the AND programming in the Basys 3 kit. So in the search button, click and type Basys, BA. If you type BA, the Basys 3 will be coming up. It will be searched and picked up. So if you click that one and click next, then click finish. So the kit is automatically assigned by the software. So what are the pins, what are the pin configuration, what are the details present in that board, everything will be automatically picked up. So this is your full Vivado software window. Here you can see these are the project managers. Okay, flow navigator, we will call this pan as a flow navigator. Here you have the source window will be there. So you can see source window, properties window. Here you have the different tabs for console, input output ports, what the different log files, everything will be there. And here you can see the project summary here. This is the space for the program editing editor also. Here only we can see project summary, program, we can edit the program, everything done be here. So after opening up, just click in the source window, you just click design source, right click it, click add source, select add or create design source. It will be selected automatically. Just no need to do any change. Just click next. Here you select create file. You create file. I'm going to simulate AND gate programming using Verilog. So here by default Verilog will be selected. If you want to change, if you are simulating VHDL, you can select VHDL. So by default Verilog, I'm giving as a file name as test, and I'm going to test the AND gates. Click OK and then click finish. So in this window you can define the input output ports, number of bits for the each and every ports will be there. By this window itself you can create it, or you can create by writing the program. Now I am not giving anything here, just I am writing in the program. Just click yes. Now in the design source you can see the file what I created, test .v. Verilog programming will be having the dot extension as .v, so that will be coming. So if you double click that file, editor window opened here. So you can see editor window open. By default, these things will be there. Okay, here you have to write the program. So what is the program? What you want to write it? Verilog program. So that one I am writing here. Okay, module and gate ABC input output ports I'm giving, declaration, functional statement, and end module. If the program what is written here, if it is correct means, so you will get the color of the indication will be green, which means that there is no errors. If the color is red, you have to check it where the mistake is. So here I have Mr. semicolon. When I correct all the errors, you can see this one will be changing to green. When it is changed to green, there is no error, coding error is not there. After clicking click save, now we have created one Verilog source. We have written the coding and the compilation also done. Next thing, we have to simulate and see the function. For simulating, you can click on run simulation in the flow navigator, click run behavioral simulation. So simulation window will be opened up. So this is a simulation window which has opened. You can see what are the scopes, what are the objects. Objects means input and output pins, and here you have the wave window. So by simulation means we will be giving the input and we will be verifying the output. For giving the input, I am right clicking in this one. Just right clicking, click force constant. Here I am giving the value as 0. Okay, 0. And for the B, let me give the value as 1 and click OK. So now what are the values are given? 0 and 1 has been assigned to the variable A and B, so which is input. Don't assign values for C, because C is an output P. So you have to run this program. For running, click on this run button here, run for a particular time period. So here time period is mentioned. Just click the time period and you can see the waveforms here. So now AND gate means input is 0, output is 0. Input A is 0, input B is 1, so output will be 0. Now changing the value again, I'm changing the value of A to 1. So now A is 1, B is 1. We'll see what is the output. So the output has been changed here. You can see changed here. The waveform has gone outside. So to see the waveforms in this window, click this button, zoom fit. So all this thing will be coming. So you can verify this. Here, here the A is 1, B is 1, output C is also 1. Previous one, A is 0, B is 1, output is 0. So likewise, now I am changing to both the values to 0. A is 0 and B is also 0. After clicking and running it, I am getting this value here. So A is 0, B is 0, then the output C is also 0. Okay, so this is how you can give the different inputs and verify the simulation. After simulation, you can go for RTL analysis. So in this, click elaborated design. Just click OK. Elaborated design will be opening. RTL analysis will be performed. The coding what we have written is converted into a resistor transistor logic. So RTL. So how it is converted, that one we will see in terms of an RTL diagram. So this is how your coding has been converted into an hardware. So we have written AND gate. So two inputs A and B and output is C. After performing RTL analysis, going to the synthesis, just click run synthesis here, just click OK. Synthesis will be done. you can see the synthesis running here. So running, it is green color is blinking, so synthesis is running here. We should wait until the synthesis is complete. Okay, next, after the synthesis has been completed, click run implementation. Just click OK and OK. Implementation will be running. At the top right corner, you can see initializing design. So this will be running. After running, we must give input output port pins, and then we have to connect the kit to the computer, and then we have to see the output. In the meantime, I will tell about the kit Basys 3 kit. You can see this. So this is a Basys 3 kit what we have in our laboratory. In this Basys 3 kit only we are going to implement all the projects. If you open the cover and if you take the kit, so this is the Basys 3 kit what we are going to use it to verify our functions. So this one is a product of the Digiland and Corel Technologies. They have given they have supplied this for us. Okay, so here you can see this is the main IC, Artix IC, and these are the input pins, and in the here the LEDs. These are the LEDs, output LEDs. So various functions can be done by using this one. So these are the serial ports. This is power button, RS-232 cable, USB cable, push buttons. Many functions can be done by using this Basys 3 kit. Okay, so what you are going to do is, in this kit we will be using any two. These are the switches. Switches means it will be this is under logic 0. If you want to turn on, it will be logic 1. So logic 0, logic 1, these number of switches are there. This switch numbers has been given here. You can see this here, V17, so V17, V16, W16. So these are the switch numbers given here, and also for the LEDs the number is given. You can see this LED U16 is one LED, second is E19 second LED, that is LED 0, LED 1 E19, LED 2 U19, LED 3, likewise it goes on. We have up to 15 LEDs and 15 switches. For verification of our AND gate, we will be using these LEDs and switches as an inputs and outputs. So now the implementation has been done. So just click open implementation, just click yes. When the implementation is opened up, okay, you can see many number of new tabs opened here. Here input output ports will be there. Just click input output ports. Here all ports. You expand the scalar ports. What are the input output ports? What we have given A, B, that will be input, C is output. Here this was the package pins. What you are going to do, what you are going to give, in which switch I am giving as an input, which LED I am taking as an output. So here I am taking the kit, I am taking the V17 as a input B and V16 as input A. So here I am writing V16 and V17, two inputs, and here I am giving LED as one LED U16. So U16 I am giving as U16 one LED. Okay, now for this input output standard, I will be giving LB CMOS33, that is a constant which you are using for the Basys 3 kit. After assigning the pins and input output standard, we can go for generating bit stream. Okay, generating bit stream. Before that, we can connect the kit to the computer. So taking the USB cable, connecting one end of the USB cable to the USB port of the system, and connecting other end to the USB port. You can see this port you have to connect it. After connecting, if you press, this is your power button, if you press switch on, so the LED will be glowing. You can see this. After connecting, if you switch it on, 2 LEDs will be glowing. So this is your power LED. So the kit is connected to the computer via USB port. Okay, now after connecting, you can go to generate bit stream here. Generate bit stream, just click save, click OK. Just give any name. Just click OK. The synthesis design is running here. You can check it, the status here. After it is running, hardware manager will be open, which means that it will be detecting the hardware, that is detecting the kit what we have connected to the system, and then we can program the kit. The bit stream is generating. It will take a little bit of time. It is performing various functions. You can see it is performing root design. Initially it will be performing synthesis, implementation, everything will be performing. Background, we have many tasks will be running. Okay, after the bit stream has been generated, you can view the report or you can open the hardware. I am clicking open hardware manager and then clicking OK. Hardware manager will be opened up. Okay, so here you can see the open target. Just click auto connect. In background it will be searching whether the hardware is connected or not. Once the hardware is connected, you can see the hardware what is connected to the system. Just click that. Okay, no need to click, just you can see. Next, after the hardware is detected, the thing will be changed to program device or refresh device. This program device is used to program the kit. Now clicking program device, just click program. The bit file what it is generated by using the generate bit stream will be assigned to default. Just no need to do anything, just click program. Now the programming will be done. The kit will be programmed. Okay, after the kit is programmed, you can verify the inputs, give the inputs and outputs. I told I am giving the first switch as A and second switch as B and LED 1. Now both the switches are in logic 0, that is A0 B0. AND gate means both the inputs high, we will get 1. So I'm changing any one of the inputs to high. So first one 0, this one 0 0 logic, and 0 1 logic, output is 0, and 1 0 logic, here also 1 0 logic, output is 0. And when I click 1 1, the LED starts glowing. So 1 1 means logic 1. If I change any one of the inputs to logic 0, output is 0, the LED is off. So likewise we can change the inputs and outputs. Okay, so now the LED is glowing, which means that AND gate function is verified. Okay, so by this way you can connect, use the Vivado software for implementing your design. Here I have taken simply and simple AND gates. Okay, if you want to change the program, means also you can change it, you can run different programs, and then you can verify the output. Here what the program what we are given, it will be stored in the RAM memory of the device. Once you switch off and switch it on the kit, it will be vanished, program will be vanished. If you switch it, you can see that LED is glowing, which means that output output is there. Now if I switch it on, when I switch it off the kit, the hardware will be not detected, it will be showing error. Okay, when I switch on again, the LED is not glowing, since the program in this kit has been erased. Okay, so this is how you can verify and program by using Vivado software. Thank you.